Hi students! Today these notes will be over segments, midpoints, and bisectors, and they will wrap up our first unit. A midpoint is a location. You're finding where the point is that is halfway between or in the middle of two other points. So this is not to be confused with the word between, which between means somewhere between the 2 points, and midpoint means right in the middle of the 2 points. Just like with the distance formula, we had two, one for the number line and one for the coordinate grid. We also have two formulas that help us to locate the midpoint, both on a number line and on a coordinate grid. To locate the midpoint on a number line, you're going to take the values of the two endpoints, we'll call them A and B, and we're going to add them together and divide by 2. That might look familiar to average. You're basically averaging or finding the mean of the two endpoints. So we'll do an example like that. For a coordinate grid, again, we'll have the coordinates of 2 points. So we'll have an x, a y, and another x and y. And it's basically just like the number line formula. For the x value of the midpoint, you're going to add the two x values together and divide by 2. For the y value of the midpoint, you're going to add the two y values together and also divide by 2. So these are the two formulas that we're going to be using in these notes. Write these down. In this first example, we're finding the coordinate of the midpoint. Remember the location of the midpoint of segment RS. So segment RS would be the segment that connects R and S. So we're going to look at the values at each endpoint. We have -2 and +9. Now our formula says to add those two together. So remember it's A plus B divided by 2. Our two values of our endpoints are -2, and we're going to add that with +9, and then we're going to divide that by 2. -2 plus +9 is 7, and then if I divide that by 2, I get 3.5 or 3.5. So this should be the location, right about here, of my midpoint. What you can also do is kind of like in junior high when you were finding median, you can kind of count in from each side until you reach the middle. So if your numbers aren't too big on the number line, we can just count in. So we can go 1, 2, 1, 2, and we just count in on each side. And then right between 3 and 4, we would just count in a half each, and then we'd be right there at 3.5. So the answer is 3.5. Here's an application of the midpoint that requires some algebra. Notice there's also not a picture, so we will need to draw one. It says B is the midpoint of segment AC. So the first thing we need to do is draw this segment. We've got A and C at the endpoints. And we know that B is right in the middle because it says that it's the midpoint. Now there's a way to indicate this on a picture, and that's with a tick mark through AB and a tick mark through BC. If you see a tick mark like this through two different segments, then that indicates that they are equal in length or congruent. We'll talk more about this later, but just know that AB equals BC. So this distance right here has to equal this distance if B truly is in the center. So let's see what else we know. We know AB's length is Z plus 2, so I'm going to add that to my picture. And we know that BC's length is 2Z minus 6, so I'm going to add that to my picture. Because we know that these two lengths are equal, we can write them with an equal sign between them, and then we can solve that equation to find Z, which is what is being asked. 2Z minus 6. So we have set the two expressions equal to each other. So let's go ahead and solve. We're going to get our Z's on one side, either the left or the right. I'm going to move them to the right because I think it might be easier. So to move that 1Z to the right, I'm going to subtract 1Z from both sides. 1z minus 1z is 0. Bring down the 2 on the left. 2z minus 1z is 1z, but remember I don't have to put the 1. I can just put z minus 6. So I've got all my z's on the right. Now we got to move our constants to the other side, which is the left. To move that minus 6, I'm going to add 6 to both sides. When I add 6 to minus 6, I get 0. 2 plus 6 is 8 on the left. We've got z on the right. We've isolated our z. So that means z has a value of 8. If there was a follow-up question that said, how long are A, B, and BC? That's when I can go up here and I can plug it in to both of my z's to find their actual length. Here's an example of finding the location of the midpoint on a coordinate grid system. I'm just going to quickly sketch these 2 points just so we can kind of have a visual representation of what we're finding algebraically. So point E is at -2, 4. Here's point E. Point F is at +3, 1. Good Lord, sorry guys. Here's F. So this segment EF, I'm trying to locate its middle, what's right in the middle. Okay, now I could take a guess, but I want to be absolutely sure, so I'm going to use my formula. So let's write down what the formula is. The midpoint, I'm just going to abbreviate like this, is equal to the average of our two x values, so x1 plus x2 divided by 2 to find the new x value, and then we're going to average the two y values of my endpoints. We're going to add them and divide by 2 to find the y value of my midpoint. So let's go ahead and do this. Here are the x and y's. I always label them. Remember the x1 and the x2 and the y1 and the y2. It doesn't matter which point they come from because we're adding them together. So it doesn't matter which one you put first or second. Let's go ahead. So our two x values are -2 and 3. We're going to add those. Make sure you're not subtracting like you do in the distance formula. The distance formula is you're subtracting. The midpoint formula is you're adding. Sometimes students get those mixed up. My two y values are 4 and 1, so we're going to add those, and then we'll divide that by 2. Now we have to simplify. -2 plus 3 is 1 divided by 2. 4 plus 1 is 5 divided by 2. Now, in order for these numbers to make sense to us, I may want to convert them to either mixed numbers or decimal numbers. That might help you see it a little bit better. So 1/2 is like 0.5. And 5/2 is like 2.5. So this would be the location of the midpoint of this segment. And if I was to kind of sketch it in, it would be about right here. And we could call it M for midpoint if we want to. This example is not to find the midpoint, but it's to use one endpoint and the midpoint to find the other endpoint. So you're kind of working backwards here. It says M is the midpoint of AB, segment AB. If A has coordinates 3, 5, and M has coordinates -2, 1, then find the coordinates of B. So I'm going to quickly sketch just so I can get a visual of what's happening here. A is at 3, 5. So there's my A. M is at -2, 1. So there's my M. If M is in the midpoint of AB, then that means B has to be somewhere on the other side of M, may even go off my paper. So over here somewhere. And I'm guessing that's in the third quadrant. So to kind of check my answer, we need to make sure that those coordinates of B are both negative, because that's kind of what it looks like to me. So here's kind of the trick of how to do this. Whenever you know the midpoint and an endpoint, you're trying to find the other endpoint, I always line it up. So A is 3, 5. M, which is in the middle, is -2, 1. And then B, which is on the other side of M, we don't know, right? We're trying to figure it out. So one of the ways you can do this is by looking for a pattern. Okay, let's take a look first at our x values. To go from 3 to negative 2, I'm going down by 5. So if I go down by 5 again from negative 2, then I'm going to get to negative 7. Okay, let's look at the y values. To go from 5 to 1, I'm going down 4. So to go down 4 again from 1, I'm going to negative 3. So based off this should be my location of the other endpoint, negative 7, negative 3. And I know this is just a sketch, but that kind of makes sense with my picture, right? So what you're actually doing, you're actually using slope to keep going down your segment to find the other endpoint. So it's kind of like this. If I look at A, my y's, I'm going down 1, 2, 3, 4 units. And my x's, I'm going to the left 1, 2, 3, 4, 5. So I'm going down 4 to the left 5. And then I'm basically just continuing that pattern again. 1, 2, 3, 4. 1, 2, 3, 4, 5 to get to B. So this is kind of like an easy way to find that. Otherwise, these kind of problems can be a little tricky, but this is the trick that I found that works really well. The other term that we're learning about is what a segment bisector is. To bisect something means to cut it right in the middle, And we are going to be cutting a segment in the middle. So the things that do the cutting can be a point, line, ray, segment, or plane. Basically, all of the things that we learned about in our first lesson. And they're going to intersect or cross the segment at its midpoint. So a segment bisector finds the midpoint of a segment. So for example, if I have this segment and something, whether it's a point, a line, right? It could be a ray, it could be a plane, a segment. If it bisects this segment, it is going through the segment at that midpoint. And then the further thing we can say about it is that if I know where the midpoint of a segment is, then I know that the length on either side of it, this piece and this piece, are equal to each other. And that's going to help me create any equations that I might need to set up. This example says that B is between A and C. So let's draw that. Now remember, between doesn't necessarily mean right in the middle. So if here's A and here's C, B can be anywhere on that segment. I'm going to purposely put it off center looking so that I don't assume that it's in the middle. It says that AB, or the distance between A and B, has a length of the expression 2y plus 6. It says that BC has a length of y plus 8. And that AC, the whole thing, has a length of 20. Now we learned last lesson how to set up an equation that would help us to find the value of y. After we find the value of y, we're going to go back and determine if B is truly a bisector, or in other words, the midpoint of that segment AC. So if you recall, if I add a part of a segment with another part of the segment, then it should equal the whole length. So we're going to say AB plus BC equals AC. Let's plug in the expressions now. AB is 2y plus 6. If I add that to BC, which is y plus 8, it should equal AC, which is 20. So let's go ahead and solve this equation for y. I'm going to first combine my like terms. 2y and y, or 2y and 1y, will combine to make 3y. 6 and 8 will combine to make 14, and that equals 20. Now that my y's are together on one side, I'm going to move my constants to the other side. So to move that 14, I'm going to subtract 14 on both sides. 14 from 14 makes 0. So 3y equals 20 minus 14 is 6. To get rid of the 3, I'm going to divide both sides by that 3. So y equals 2. We found the first part of the problem. Now we're going to go back and determine if B truly is in the center or not. And the way to tell is if AB and BC actually equal each other. We're not going to assume that they're equal. We're going to prove that they're equal. So let's evaluate both of them. AB is 2y plus 6. So now that I know what y is, I'm going to plug it in for y here. So 2 times 2 plus 6, and I'm going to simplify. 2 times 2 is 4, 4 plus 6 is 10. If AB equals 10, that is half of AC, which is 20, which by default means that BC also equals 10. If you just want to be absolute sure, go ahead and plug it into BC's expression as well. BC is y plus 8, so if I put the 2 where y is, 2 plus 8 also equals 10. So because AB and BC are both equal to 10, and I can show that with my tick marks, that means yes, B is the bisector. These last 4 examples are going to all use the same picture. Sometimes that will happen. I suggest don't mark up the same picture with all the information because they're individual problems. I suggest redrawing the picture for each example or each problem. Let's see what the picture says though. It says segment WY bisects segment UV at Y, which means, remember bisects means to cut at the middle. So Y is now halfway between U and V. So I can say that UY, the segment, is equal to YV, this segment. And I put a tick mark through both of them to indicate that they are equal. So I can use that concept or that relationship to help me answer numbers 6, 7, 8, and 9. So let's see what example 6 says. If UY equals 5, so I'm going to label my picture, then find YV. Well, if UY and YV are equal, then YV also equals 5. And then UV, which is just UY plus YV, is 5 plus 5. So UV equals 10. Pretty simple. No equations we had to make here. This is a U. All right, let's try another one. So just like before, we know that UY equals YV because YW bisects UV at Y, so Y is the midpoint. All right, in this one, it says UY is 4x minus 3, and YV equals x, and we need to find the length of both of those. Well, in order to do that, I need to find x. In order to find x, I need to create an equation. So based off the relationship in my picture, I know that UY equals YV. So we can replace those with their expressions. UY is 4x minus 3, and YV is x. So let's go ahead and solve this equation. We need to get our x's on the same side. I would like to move my x's to the right. It's up to you. You can move them to the left if you'd like. So to move my 4x to the right, I'm going to subtract 4x from both sides. 4x minus 4x is 0. I've got negative 3 on the left. I've got 1x minus 4x on the right, which is negative 3x. Last step, I'm going to divide both sides by that coefficient of negative 3. Negative 3 divided by negative 3 is 1. So 1x equals negative 3 divided by negative 3, which is a positive 1. So there's the value of x. But it's asking for UY and UV. So this is where we have to plug them in. Now we know the two lengths are equal. So if YV equals x and x equals 1, then YV is 1. Oh, that's not what it asked for. But if YV is 1, then that means UY is also 1, right? Because they're equal. If you want to verify that, you can use the expression for UY, which is 4x minus 3, and you can replace x with 1 because that's what it equals. 4 times 1 minus 3, 4 times 1 is 4, 4 minus 3 is 1. So yes, uy also equals 1. uv, remember, is just yv plus ui added together, so basically 1 plus 1, uv equals 2. So uv is 2 and uy is 1. Here's a pretty easy one. If uv, the whole thing, is 18 and uy is 9, find yv. Well, if uy and yv are equal, then yv also needs to be 9 because they're the same and they add up to 18. So yv equals 9. No equation necessary here. Last one. uv, the whole thing, equals x plus 6. uy, which is half, is x minus 1. We need to find the length of the other half. So the relationship here is still uy equals yv. However, we don't have an expression for yv. We have two options here. We can say that if I have two uys, so x minus 1 times 2, all right, basically 2 halves, that should equal the whole thing, x plus 6. Okay, we could also think of it another way. We could think of it as 1 half, which is x minus 1, equals the whole thing divided by 2. Now these two equations mean exactly the same thing. However, the one on the left is going to require one less step. So let's just go ahead and use that one to solve. All right, so let's go ahead and solve this. So the first thing we need to do is distribute that 2. 2 times x is 2x. 2 times negative 1 is negative 2. And that equals x plus 6. Now we'll move our x's to the same side. I'm going to move them to the left this time. That 1x on the right, I'm going to move by subtracting 1x from both sides. 1x minus 1x is 0. 2x minus 1x is 1x, or just x. And I still have minus 2 on the left and 6 on the right. Last thing to do is move that minus 2 to the right by adding it to both sides. So x equals 8. 6 plus 2 is 8. So it is asking us to find yv though. yv equals uy, which equals x minus 1. So yv also equals x minus 1. Since we know that x is 8, we're going to plug it in with 8. And 8 minus 1 is 7. So yv has a length of 7. If I had another question that said, well, what is uv, the whole thing? We could say 7 plus 7 is 14. Or we could plug in that 8 here for x. 8 plus 6 equals 14. All right, guys, bring me some questions, the examples you had problems with to class, and we'll wrap up this unit and start getting ready for our test. Y'all are doing a really great job.